Welcome back to another episode of Learning Vue.js the hard way, and in this episode we are going to talk about watchers. In the last episode we talked about computed properties, but there's also this concept of watchers in Vue.js. By the way, Vue.js, learning Vue.js the hard way, what I mean with the hard way is that we are learning Vue.js by reading through the documentation or reading through the get started guide. But if you're in this episode, I assume you've watched at least a few of the other episodes, so you know what's going on, so let's just dive straight into it. So again, in the section Computer Properties and Watchers, we're now going to talk about watchers. Let's actually start in this subsection here that we skipped last time. So last time I mentioned that there's a subsection called Computed versus Watched Property. But we didn't talk about that since we didn't talk about watched properties. And I understand that I haven't necessarily yet explained exactly what a watched property is, but let's sort of talk about what's in this section before we go any further. Let me actually say, a watched property is, so a computed property is a property that can be derived as a calculation from the values of other properties, right? So we looked at, for example, full name, and so full name is sort of a computation that's based on the composition of first name and last name, for example, right? But you might have anything, right? It's like you might have, like, let's say the length of a list is in some sense a computed, or could be seen as a computed property because it's the number of elements in a particular list. But you might, as we looked at in the last episode as well, you might have more complicated scenarios where you have something like, let's say that you have a list of objects rather than a list of simple. So let's say you don't want. Let's say you're not actually caring about. Let's say the number of items in a list. Actually, this makes sense. Let's say you have a to-do list. You have a to-do list where each of the items in the to-do list might either be completed or not completed. So a computed property might, for example, be the list of all completed items, or a computed property might be the list of all remaining items, or like the length of the amount of completed items, so the number of completed items versus the number of uncompleted items, and so forth, right? Like there are a bunch of different things you can do. You could even say that, like, let's say I was going to say that a search would be a computed property, but not really, right? Because then it's more, you should probably think about that more as a, no, but actually, actually, sorry, you could consider it that way. I was going to say that it's more of a function because you need to have input, but you could say that the search string is a, for simplicity's sake, two-way bound property that's bound to an input box, and whenever you type into that input box, you're changing a value which is like the current query, and then you use that query and you construct a computed property that's computing the search result. Like, let's say you're dealing with something that's local, right? It's like, let's say you have a list of to-dos, and then you have this sort of filter text bar where you sort of want to filter on all of the things that match some particular criteria. Then the computed property of the list of the things that match, like those could be, that could be a computed property that's based on all of the to-do items and also the search query, right? But okay, so now we're just taking examples of what computed properties could be. But yeah, again, if you haven't watched the last video, definitely watch that if you're more interested in computer properties. But then there's also this concept of a watched property. So what is a watched property, right? So watched is sort of a more imperative way of approaching a sort of, let's say, similar problem, right? So the similar problem is, or I mean, the general problem here is that you have something that you want to observe some particular observable, you want to observe some particular other property, and then you want to do something whenever that thing changes. And the difference here is in whether you want to do something, as in imperatively execute this piece of code, or whether you simply want to compute a new property, right? So let me put it another way. Computing the full name on the basis of first name and last name, that's a pure operation, right? If you're familiar with the idea of purity from functional programming. So purity, I'm not going to go into this, but deeply, but purity means that whenever you pass some particular input, you always get the same output, like roughly speaking, right? It's like if you have a function called f, and if you pass 5, then you should always get back the same result. It can't be that sometimes when you pass 5, you get one result, but sometimes when you pass 5, you get another result. Like if you have something that deals with randomness, for example, then that thing is not pure, for example. So I'm not saying that all computed properties have to be pure, but like as a general, whoa, hope the sound is still okay. Sorry about that. Okay. As a general rule of thumb, if you can express it as a pure function, then it's probably suitable as a computed property. And maybe there are some scenarios where it doesn't necessarily have to be pure. But the point is that we are not dealing with if you think about commands, maybe you're familiar with the idea of command query separation from object-oriented programming. If you're not, I actually have a video on that, like a code walks video, pretty old video, but definitely check that out. The idea of command query separation is pretty old, and is actually a very, very good idea, in my humble opinion, right? It's like the idea of, and in some sense, I would even say that like things like React are sort of partially based on that idea. Whether they would call it command query separation is a totally different topic, right? And like probably they wouldn't, because the idea of command query separation probably also stems from older ideas than that. But I think that's a very sensible way of thinking about it. So command query separation simply says that either something is a command or it is a query. But you should not mix things that are both commands and queries. You should never do both at the same time, right? So what is a command? A command is when you change something, and a query is when you compute something, right? So computing full name from first name and last name, that's a query, right? But let's say sending some data to a server, that's a command, right? Or even more simply, right? It's like taking sort of 5 plus 10 and putting that in the variable a, right? Like that's a command if that variable is now a new thing that's in scope, right? And then I wouldn't say that let's say yeah, actually, so yeah, that's a bit shady. I was thinking like, what about a setter for the computed property full name that we looked at last time, for example? Like that has to be sort of a command because you're changing, but of course it's sort of kind of not impossible, but it's kind of difficult to have a command that doesn't involve a query, right? But essentially, I mean, I guess the point is that it should rather maybe be thought of like this, right? It's like a command may include a query, but a query must never include a command. No, not as in like technically you can't. Of course you can technically, right? It's just that if you're thinking about design, you should separate the things that are pure from the things that are impure. I guess like command query separation is essentially just saying that, right? It's like take the impure things and separate them from the pure things. But okay, sorry, now we just whenever I have the chance to talk about functional programming, I guess I dive into functional programming. But what was I actually saying, right? So watchers are, I understand it as that they are mainly intended for things that are impure. So what that means is that if you're developing a local application, then that might mean reading or writing from the file system. Or it might mean that you have some asynchronous operation, right? Which might mean then that you have some kind of server call. Or it could be, what was I going to say? It could be, yeah, reading or writing to local storage, for example, right? So writing, right? Essentially, actually, I like that. We should think about it like that. Writing, yeah, but it has to be externally, right? Yeah, because if you're just setting model properties, no, yeah, exactly. You could be setting model properties that are located elsewhere. Yeah, this I should not dive into this. I don't want to express a sort of general rule here because I feel that I don't understand Vue enough yet to actually express it as a general rule. But spontaneously, it seems to me that everything that has to do with everything that's asynchronous, right, is a good candidate for a watcher. And everything else, unless I'm mistaken, can be expressed as a computed property, and hence should be expressed as a computed property, right? The reason being that computed properties are declarative, and it's easier to reason about declarative code. It's easier to reason about the dependencies than when you have when you sort of move into then when you move into this imperative land where you're saying sort of first do this thing, then do that thing, then do this thing, and so forth. And that's what they're saying. That's where I was trying to get at. That's what they're saying here in this section, right? It's like it's very tempting to overuse watch because it's very simple. But generally, I would say the thing that you should use is a computed property. And if you can't use a computed property, then look into watch, right? And that's, again, like it seems that the general rule would probably be anything that's asynchronous. Because also, I mean, this got me thinking. They mentioned asynchronous somewhere here. Yeah, if you have asynchronous or expensive operations in response to changing data. Okay, so they're saying, yeah, okay. So it seems like the general rule is asynchronicity, right? But then they're also tacking in this thing about expensive operations. So they're saying that maybe sometimes you want to limit let's say for this way, like in this sense, you can they have an example here where they're debouncing, and debouncing means that they're sort of, or maybe throttling. Oof, I always mess up which one is which one. They're doing debouncing, right? And debounce is here to limit how often a particularly expensive operation can be run. Yeah, exactly. So debouncing. So what I'm saying is that if you have a calculation that you don't want to compute too often, let's say as we talked about before, like let's say as a search, for example. So a search, even though it could be expressed as a computed property, if it's based on a very large data set, you might not want to execute that search on every keystroke. Now, if it's a to-do list with like 150 to-dos, I wouldn't even worry about that, right? I would just make it a computed property and be done with it and sort of move on with my life. But if I have a search of, I don't know, like 100,000 to-dos, right? Even if they're local, right? Even if they're not even if the operation is synchronous and not asynchronous, I would probably maybe look into Watcher, right? I would sort of look what it check how it behaves as a computed property if it's fast enough. But depending on the complexity of the search, it might not actually be fast enough, and then you might want to do a Watcher. And then so the reason you're doing a Watcher is that gives you the ability to say that even though the property has changed, I don't want to recompute the property yet. Recompute the computed property yet. But with the computed property, you have to compute it every time, right? So it's like, you can think about it this way. It's like a function is computed all the time, right? A method, sorry, they call it the method. A method on the options object is recomputed every time there's a re-render. But then you have computed properties, and computed properties are only re-rendered whenever there are changes to their constituent parts, right? Whenever there are changes to the observables, to the data pieces, to the data properties that particular computed property depends on. But then there are watchers, right? And with watchers, you have full control. You can say, I want to listen to this property, and this property. And whenever one of those changes, I want to be able to determine what I want to do. And then you can start to do things such as debouncing, such as saying, or throttling, right? Like saying like, well, it seems that the user, or something like this. It was less than a second since the last time the user has typed has typed in something new in the text box, right? So I will, yeah, okay, I don't actually remember. So debouncing probably doesn't work like that, right? And if it's a search, you want the latest the latest data. So what you probably want to do is something like that. When there is a change to the data that you're watching, you would say, in 2 seconds, I will start to, or in a second, let's say, in 1,000 milliseconds, I will start to compute this search query. But if I receive another keystroke, if there's another change, I will start over the timer. I will wait, like you will sort of, so that if the user is sort of rapidly typing, then you won't fire off like 10 different search requests, but rather when 1 second after, so as soon as the user waits 1 second, then you'll fire off the like if the user stops typing for a full second, then you'll fire off the search. And again, this might be then because that's an expensive search that you're doing. But again, I'm not saying that. So I think it makes sense to sort of think of those as sort of layers. You start with the methods, then you have computed properties, and then we have watchers. And that's actually like, it seems to me that was a very good way for them, all of them, to introduce these 3 different concepts, because that's also the order in which they introduce them. But watchers here, again, like now I talk about debouncing or throttling. Let me just make it very clear that debouncing and throttling has nothing to do with watchers. Now you can use watchers for like anything that's asynchronous or expensive. But one such example would be, for example, debouncing. So if you want to do debouncing, probably you're going to have to look at watchers. And again, so also, of course, asynchronous operations. So that means that if you are loading some data from a server, or if you're sending some data to a server, right? It's like, I mean, the user has entered some data into a form, and then, actually I was going to say, and then they click, yeah, but it's not about clicking send, right? Because if you click send, then you probably execute a method, and then you use that method to just send off the data that you need to send off. But watchers is something that's dependent on some observable, right? Watchers are fired whenever some data that you're depending on is changed. So, but yeah, I mean, again, it could be. Yeah, okay, so again, so let's say the search example again. Sorry for not coming up with more sensible examples, but it might be a search that's dependent on data that's in the cloud, right? It's like this, let's say a Google search, right? It's like you open up Google and then you have this sort of you get this prompt back of suggestions, right? So maybe you would use a watcher then to debounce so that you're not sending requests to the server like all the time. And then you would send off the request, and you would get back some kind of list of suggestions, and then you would populate a variable in your data model with the contents that you get back, right? And actually, there are two problems here, right? Like one is the sort of expensive part, and that's why we're doing the debouncing, right? But that's independent of the asynchronicity part. So like again, you might want to use a watcher if you have an expensive computation, so that you can do something like debouncing. But if you have, that's like regardless of whether you have asynchronous or synchronous data. But the really let's say, in my mind, key point as to why you would need a watcher over a computed property is if you have an asynchronous operation, because then you can't. So I'm assuming now you are familiar with promises, for example. So if you are familiar with promises, then you might think spontaneously that you could pass a Vue template a promise. Like I was thinking that maybe that should work, like that would be a good thing. And then whenever the promise resolves, then the Vue would show that particular piece of data. Now, Vue doesn't work this way, right? And there are probably some good reasons for that, like they're sticking sort of to primitives. So that means that at least that's the way I understand it. I sort of searched around for it a bit, and I couldn't find any evidence of the contrary. But that means that if you want to work with a promise, if you want to interact with a data source that gives you a promise back that you then want to set to some particular model, then you need to use a watcher. Unless you're of course using a function, right? Or sorry, a method, right? But like a method is invoked whenever the user, like you have to bind the method to something, such as, like, for example, a click. But again, you might use the watcher if you want to get back but you have to use a watcher if you want to invoke this asynchronous operation that could then, for example, be a network request. If the firing off of that thing is dependent on something like another property changing, such as, for example, a search string, right? So like think of this as the difference between a changing search string, watching over the fact that the user is typing in a search box, reacting to the fact that the user is typing in a search box, versus the user actually clicking search, right? Like those are two different things. Whereas if you're clicking search, then probably you should simply use a method, right? Because that's probably more clear. But if you are watching or reacting to the fact that the user is typing into the text box, then using a watcher probably makes sense, or is probably inevitable if I think about it, right? Not inevitable. I guess you could sort of bind. Yeah, I guess you could bind to on data, like on key event or whatever that's called, like on changed on the input box, and then run your method. That would probably be sort of equivalent, right? So I guess it's sort of also a level of abstraction thing. Let me. I think we need to dive into the code now because it's becoming increasingly unclear. So if we have this index HTML file that we've had from before, what I mean is that you have this input field here of fruit, for example. Let's open up this particular HTML file. Let me make the font size bigger, and then let's just add another. Let's do something more up here in the top. Maybe let's put it here. So let's add another input field where I can say something like default, right? So let's add just a search text. Let's refresh that. No, I can't add. wait, input default value HTML. No, placeholder, sorry, that's what I was looking for, not default. Placeholder, so that I didn't have to specify a label. Yeah, search. Okay, so here's a search bar, right? Let's say. So the question is, if you wanted to bind to changes in the input field, let's figure out what that's called. Input on changed HTML, let's say. Maybe it should be JavaScript. Change, yeah, exactly. Input for change to an element's value. It's not changed for value? Unlike the input event, the change event is not necessarily for... Okay, for each. Okay. No, but so it seems like this would be the thing that we're looking for. Let's just try this, right? So we could say something like on... So now I'm using the shorthand syntax that we talked about in another episode. So at the event change, we want to run a search, let's say. And then we also want to bind this... we want to bind the property that we are, or the value that we have in this input field to, let's say, a query. Let's call the variable a query. Now let's jump over to main.js. Let's define the query variable. So let's say in our data model we have a query variable. It's going to start as an empty string, and then we need a method which is search, right? And the only thing I'm going to do with this is I'm just going to console log the search query, just to see that, whoops, what am I doing? Just to see that we are actually hitting the, like we are actually, our things are wired up correctly, right? Searching for, and then let's say plus this dot query, right? So let's run that, and let's look in the console here. We can see we have a warning. Property or method num entries is not defined on the instance. Ooh, okay, so this is sorry, this is some stuff from last time that I've probably forgot to clean up. So yeah, we have num entries here left in the template. I'm just going to remove that because that was from the last episode, and it doesn't really matter now. Okay, so now we have the search box, and we're going to sort of keep our eyes on the console here to see if we get any output. So if I start typing here, there's no output. But what if I click outside? Yeah, okay. So it seems like the change event of the input field is only reacting to, like, when I actually leave, when I unfocus this particular text box. So that's not extremely helpful, right? And so actually you probably need some more sophistication in terms of how you listen to the changes of this input field, and it's probably entirely possible. But the point I wanted to make is that, of course, you could use you could bind to some particular event and then use a regular method in order to react to the fact that you now have a new search string. But if we happen to have this query variable, then maybe it's unnecessarily complicated to just say that, to sort of wire this up in the template level, because that's what I was trying to get at with, like, the different levels. It's like, either you can bind the reaction, or like the reactivity, you can bind the sort of re-invocation of the search, or like the research, the re-invocation of the search method. You can either wire that up at the template level, or you can wire that up at the model level. And I actually think it makes sense to wire that up at the model level, right? Because it's like you're saying, it doesn't matter how you visually change the query. If you change the query, then the model specifies that there's a dependency such that when the query has been changed, then the search needs to be re-executed. I actually think that makes more sense than binding in the template, right? So it's not just that it's easier, perhaps, in terms of setting up the bindings. It's actually, like, I think semantically it kind of makes sense. So let's say, I mean, if we only have this, right? If we only bind to the query variable, of course, now nothing happens. If I refresh and type here, like, nothing happens. But I can say vm dot, what did we call it, query, right? And I should be able to get this text, right? So we're actually two-way binding this field to this particular value. Okay, so how can we react to that? Let's construct, let's remove the, or close this change documentation. Let's now construct let's keep the console open, actually. But let's now construct a watcher for that. So let's look at an example of what a watcher might look like. La 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 la. Here, watch. Okay, so actually, I mean, I gotta say, I'm actually impressed by the level of simplicity of Vue. Right? Notice like every concept that we've come across so far has been a root property of the options object to Vue instance, right? So it's like you have this Vue instance, and it's like we just step by step we just learn about L, like the EL, like the element that we render into. We learned about template, right, which is a root level property. We learned about props, which is a root level property. We learned about the data object, right, which is like the data that you're binding to. We learned about methods, which are the methods that you can call from a template or like from other methods within here, I guess. Yeah, from other methods within the instance. We learned about computed, right, which are computed properties, the last episode. And then we've learned about hooks, right, another episode. But all of these things you just sort of specify in the options object of a Vue instance or a Vue component. So it's like, I mean, I'm just impressed by the simplicity. That's what I'm trying to say. So the next thing that we're learning now is watchers, right? And watches, of course, then just another property that you pass in, or that you add to your options object. And so it's called watch, and it's of course an object because you can watch multiple things. And I guess the point here is that they're specifying question here as the key, and that's probably the thing that they are watching. So we should specify query, right? Because query is the thing that we are watching, and then we want to have a function. And okay, so this is cool. So it seems that the watcher is taking two arguments, where the two arguments are the new value and then the old value. And we actually only care about the new value, so let's just call it Q here, the variable here, and that's the new query, right? That's the query, the new query that the user has typed in. But if we wanted to, we could also care about the old query, the query that we're changing from. And so what do we want to do here? Well, maybe we want to console log here, right? Console, so actually I'll just remove, or I'll move this search for down here, right? The same console log, and we'll remove the search method from methods. Okay, let's save that, and let's look at this. So we should get the same console log statements here, but not only now when we unfocus this text box, we should get it all the time whenever we are changing text there. Did I save this file? Let me just save this and refresh, and let's see now. Yep. It works, right? You can see we're logging out searching for A here, right? So if I say fruits, you can see for all of the characters, searching for F, searching for FR, searching for FRU, searching for FRUI, and so forth, right? And so, of course, this is why you might want to do debouncing, right? Like notice how the stuff is changing here in the console, or what's being printed to the console as I keep typing here, right? Like if you would fire off a network request for, oh my, sorry. Just kept pressing too enthusiastically on the buttons. Oh, okay, we're back. I thought I'd close the window. So if you would have fired off a network request for all of these different things as the user was typing, then of course, like, it's likely that like the first network request might not even have finished when the user has finished typing the last one, right? So it's like completely pointless, and that's why you might want to do something like debouncing. Now, however, that's not something we're going to look at today, but if you're actually implementing some kind of networked search, or if you're actually interacting with some API where you have a user text box like this, then you should definitely look into something like debouncing or throttling, I mean, depending on your scenario. Okay. Let's fake having a promise. So let's say that we had a promise here. So let's say, or I mean, we don't even have to care about a promise. Okay, yeah. So I was thinking that we needed to care about promises, so I preemptively opened up the promise doc so we could talk a bit about that. But actually, in the sake of simplicity, or for the sake of simplicity, let's just hard code a timeout here, right? So like, let's say, yeah, okay, sorry, no, okay, maybe it would make sense. Yeah, okay, let's hard code the timeout here, and then maybe we'll move into the promises. But let's say that we'll wait 1,000 seconds. Let's not print the console now, so then I can close the console so we don't have to think about that. And then, sorry, actually I should use this function syntax so that I'm not messing up the scope of the this variable. And then I want to say something like this dot, let's say, results. So results would then maybe be the results coming back from the query, right? And then let's just add a bunch of fake data, right? Or actually, let's just do fruits like apple, pear, banana, pineapple, and so forth, whatever, right? Let's put this back on one line, actually. Okay, so then we need a results variable as well. Results is an array that's empty. Of course, now, I mean, you can see here that clearly I'm not, we're just experimenting around, and I would never actually write a data object that looks like this. Clearly, we have the need to extract different components because we're sort of mixing lots of different concepts. But again, that's just because we're experimenting. So don't worry about that, right? And then let's also put let's sort of render these results somehow. So let's add a p tag here that says results, and then I guess let's use each, right? So we'll say ul close the ul, and then li. And then we have to say v4, let's say result in results, I guess. That would make sense, right? And then we would have to render result, right? I think this would be it, right? Let's try this out. So then we have results here. And if I now start to type something here, yes, then we get back some data after 1 second, right? Let's just make that a bit more clear by moving from 1 second to 2 seconds. Let's refresh that. Let's type some data out. And then you can see we get that data back. So let's actually, so that this is a bit more dynamic, let's just maybe do something like, if we have the query, let's say that the results are the query split on empty string, let's say. So then if I type here, apple, banana, pear, pineapple, I probably have an error. No? Q split. Let's console log this. Console log Q, save, refresh, apple. Yeah, okay, I don't know why it didn't work before. Maybe I just forgot to save. Yeah. So, okay, so let's remove the console log, save and refresh. Okay, so now you can notice as I'm typing, after 2 seconds, okay, 2 seconds was painful. Let's go for 1 second, right? As I'm typing, with a 1 second delay, it's sort of rendering what's happening here, right? In the results, we're getting back these results. Banana, pineapple, right? We're getting them out, right? Whatever, right? Orange, right? Oh, sorry, orange. Something like that. Okay, so and this of course could be a network request. Now this isn't actually a search query. It's just me being silly, right? In order to sort of mock that we have a search query. Now, of course, you might have sort of abstracted your API into a different method, and then you might you might rather be getting a promise that resolves, right? So then you would maybe do something like this. Like let's say that we would call a search method instead, that we have to find the error search. Yeah, I guess method actually. And then we're searching for this Q variable, like for that string, for the query. And then we'll say maybe then, and that would be that we'll get the value here, right? If I'm remembering this correctly. And then there we would say this.results equals Q.split. So same implementation, right? Or sorry, no, we're just getting the value back. We're getting the value. So now we can abstract this away and say like, let's say fake API method here, right? So let's call that. So that's a variable, or sorry, that's a function that we call search. Is a function that takes some query and then just executes. Oh, no, I actually removed it, but it essentially does set timeout. Yep, and then it returns. So set timeout. Let's say after 1.5 seconds or 1,500 milliseconds, and it simply returns. No, sorry. Okay, we need to do a promise. So this is when we need to use. Let's just look at the promise syntax, so I'm not actually messing this up. Promises. JS promise. So just so we don't have to do this like a bazillion times because I keep forgetting. So I'm just saying return. Yeah, okay. So it's actually very simple. It's just like this. So I'm saying return a new promise containing a function that can resolve and reject. And that function will, what we will do, yeah, so then we have this stuff. So within that function, we will call set timeout. and then that will sort of be timed out after 1.5 seconds, and then we will resolve with, and now we have the implementation. So that's query dot split on empty string, right? So this is all like let me make this explicit, right? Fake API method not at all relevant for Vue, right? This is just some some stuff that we develop now just to pretend that we are fetching some data from some API when in fact we're actually not at all. So then you might interact with your, or what you specify in your watcher might be something like this. Like you call your search function, pass your query, and then you listen to whenever that returns. Like you say, like give me back the promise from calling search here, and then when the promise resolves, do this thing. And the thing that we're doing is that we're setting this.results to v. Now probably there's a more compact way of doing exactly this thing that I did now, but let's not think about that now, right? And yeah, so let's look at whether that works or not. So if I type orange here, we get orange. And notice how it's typing out every letter, because we're actually invoking this watcher. We are actually making this fake API call for every letter, right? Orange, apple, banana, whatever, right? They're sort of showing up one by one. So these are the results of our search. And of course, I mean, clearly, if I remove the delay here, let's say the delay is 1, this will like sort of appear immediate, right? Orange, let's say red, blue, white, black, green, right? It sort of appears immediate because we're faking a, like what I'm saying is the wiring up of the different pieces is of course fast, but we're faking a API call. So yeah, that's the watchers, right? Those are the watchers. And of course, as you can see, we could have used methods. We can't use computed properties, right? That's the key point, because if you think about the structure here of the watcher, we're depending on the then value. So we can't really use the computed property. Actually, if I think about it, maybe we can use it. Let's go back here to computed property setters. Yeah, maybe we could actually, but it would be like sincerely. No, wait. No, because we're not actually interested in the setter, we're interested in the getter. No, we can't use computed properties, right? Because a getter in a computed property has to return the value, and the returned value within the context of Vue cannot be a promise, right? If you return the promise, maybe we should even try that. Let's say, am I even going to try that? Let's say computed, so for simplicity's sake, right, we have this computed full name. So let's just look at that. You can see here we have the computed full name that's sort of being rendered. If I'm, instead of saying return this .f name plus space and then plus this .last name, let me just say return search for hello world, right? Or let's search for similar things, right? Apple, banana, orange. Then I'm assuming that this won't work. Yeah, you can see what we get back is actually the promise. So Vue does not sort of in the background handle handle promises, right? It doesn't handle promises in the background. So you can't pass promises to a template. And again, I don't know necessarily the reasons for this, but there might be good reasons, or there probably are good reasons for why this is not the case, or for why they're not handling that. So let me just remove that code so we're not leaving that for next time. But yeah, okay. So now we have this sort of search bar where you can search for stuff. And again, like if we were searching for, okay, it behaves a bit strangely, but whatever. If we were searching for, let's say, things that appear in this particular list, then that could have been done as a computed property, because the operation is neither expensive, because we're searching through what seems to be like a trivially small list, and it's not asynchronous, because we're searching through data that is available right now. And those are sort of, or those seem to be sort of the two conditions that determine whether you should use a watcher or something else. So generally speaking, in all other cases, don't use a watcher. There's no point, right? So I guess that's it. Let's see if we missed something. What do they have? I mean, their example is pretty complicated because they're using debouncers. Or they're introducing this additional complexity of a debouncer and also of an actual API call. So I would suggest to definitely have a look at this piece in the documentation and try this out on your own and try to make sure that you get this working. For the sake of simplicity, I just skip that, but definitely get something more complex like this working so that you know that it works. And this, what is it? Yeah, so this is what they rendered. Let's actually try this. So let's ask this thing, is it raining? I don't know what we should ask it. Thinking, no. Okay. Is it not raining? No. Is it night? Yes. Okay. I have no idea what this is, right? But that's they're interacting with some kind of API here called yesno.wtf/API. So I don't know, maybe try that out. This seems like a bit fun. Okay, and yeah, again, they're saying the same thing. Asynchronous operations, that's what they're allowing us for. And we can do more complex things, such as setting up intermediary states until we get a final answer. So yeah, again, like let's say loaders or something, or like have processed 25%, 50%, 75%, and so forth. Like a bunch of stuff. Okay, one final note here. They're saying also, in addition to the watch option, I'm just reading now, you can also use the imperative $watch API. Let's just quickly look at what that is. We're not going to talk about it in detail, but let's just get some idea what this is. So watch an expression or a computed function on the Vue instance for changes. I'm just reading the usage here, or the usage section. The callback gets called with the new value and the old value. The expression only accepts delimited paths. For more complex expressions, use a function instead. Okay, so it seems that what they're saying is that when we are passing something in through computed here, when we are passing in a value under the property computed to the options object to the Vue instance, then what's happening under, oh sorry, I said computed, or I highlighted computed, at least I don't know if I said computed, I meant watch, right? When we specify the watch property and pass some configuration here, and then implying or saying that we want to watch query, then what's happening under the hood is that they are delegating to $watch, the method $watch. So probably what we could do, the way I'm understanding this, is that if I open the console here, notice that VM is just an arbitrary name, but we happen to call our Vue instance VM as well, right? And you can see here, that's our Vue instance. So it seems that we should be able to say VM.$watch, and then what was the syntax? Pass first a string, an expression or a function, and then a callback, and then some possible options. So a string is probably the thing that we're watching. So I guess we could say, for example, let's watch query. And let me copy this and refresh just to make sure that if I say hello here, world, yeah, okay, so our old stuff still works, right? So what we could do is we could say, let's watch query, and whenever query changes, we want to execute this function that gets the new value, right? Let's only care about the new value. Or actually, let's say nval, yeah, the nval and oval, so new value and old value. And then let's say we'll just console log changing, or let's just do this, right? Let's just say oval, and then add a sort of arrow so that that's changing. We're implying that that's changing to nval, right? Let's only console log that. Whoops, nval. Missing parenthesis. Oops. Sorry, like that. Hey, function nval open console log. Yeah, sorry, I'm messing this up. That's for the console log, and that's for the function, and that's for the outer function. I'm still messing this up. That's for that. That's for that. What did I do wrong? Can I do a line break here? Line break, function, arguments. Oh, okay, sorry. I forgot to add plus signs here, of course, because of the concatenation. Okay, yep, okay, so supposedly we've now added another watcher to query. Let's try this out. Yep, hello, right? So you can see now we're getting these console logs. Let me clear this so it's more evident. We're now getting these console logs that are a result of this new watcher, right? So it's like, let's say A, B, C, right? So it's like first it's changing, the old value was A, but now the new value is AB. The old value was AB, and now it's ABC, and so forth, right? So so yeah, their point here is just that the the watch option is based on the imperative interface $watch, that method, and you can manually call that and set up a watcher. Now again, there is in some sense no need to do that unless you're doing something not esoteric, but like exotic, right? Like it seems to me that in 99% of the cases, non-real numbers, we should be able to get by simply passing in options. Like the general rule is stay as declarative as possible all the time and make sure you exhaust your options before you dive into imperative land or even like non-impure land. Wait, I'm losing my track. What I meant is exhaust all your options in staying in the declarative or the pure land before you dive into the imperative, sort of procedural impure land, right? Try to figure out how to use options and try to figure out how to use computed properties and all that stuff. Like even watch in itself is sort of only use that if you really need to. Or I mean, obviously, only use that if you need to, and then, but then again, moving from just using watch as an option to watch as in calling it on an actual instance, like what's the need for that? Then you're probably really in imperative code, and you should try to think about restructuring it so that you're passing in options instead. Okay, let me now sort of close this. The next section will be on class and style binding. So maybe then we can try to make this application look less like the 90s, I guess. Okay, thanks a ton for watching. I'm glad to have you along. Hit the like button if you appreciate the video. Remember to subscribe so that you won't miss the upcoming videos. I'm uploading videos every day. I will see you. Thanks for watching, and I will see you in the next one.